Welcome to livestream number 101. Some people will say that's a lot of live streams. Some people will say we just got started. Today's topic is all about CAM within Fusion 360. Today's topic is called Machine Fillets, Chamfers, and Rounds. I have a hard time talking. It's Friday. We made it. It is our CAM day. See, we already got a couple of people coming in here. It's absolutely awesome. Thank you for taking the time. So I'm going to cover how to do like breaking edges with chamfers, how to do round edges. So kind of like just throwing a couple of things in there when it comes to kind of like breaking the edges or fillets, chamfers with your CNC mill. And I think that there's going to be something in there for everybody, even like if you're brand new or if you actually have a little bit of experience. So hopefully you enjoy it. As usual, thumbs up if you like it, thumbs down if you don't. Also, if you haven't already, down in the description area of this video, besides my email address for any future topics, you will also find the CNC Handbook. This is a CAM we're talking about today. The CNC Handbook, I just checked. I have over like 5,800 downloads on that. And you will not receive any spam. None of those guys have. Okay, enough of this. Good to see everybody in here. Let's get going. So I modeled this part up here, not to really do anything too fancy, but really just wanted to talk. I get some questions in regard to creating 2D chamfers, 3D chamfers, how to work with breaking edges and things like that. And I wanted to share a couple of things that I used to do that really made my life easier, so maybe it can make your life easier too. First of all, if you ever get the models, some people get to model their models from scratch. Some people don't, right? Sometimes customers just gives you a file that says machine this. One thing I used to do was if I had like outside corners like this, I would actually break the edge on my CAD model, just the tiniest little bit. So I would go in here and add a chamfer, and I would literally select the outside edges on my model here and break those, and not so much for the outside, but more for like also like inside corners like these. And I would literally just break it the tiniest little bit, like 0.25. That there will break that edge when you're machining around this part. So if I like, for example, for the outside here, if I went into CAM, that's where we're supposed to be today, and I do a setup, always select Z-axis plane here, and let's select the top face. That's pretty good right there. Let's just check the stock here. Make no extra stock on top, just in case we got to verify this later. So let's go in here and create a 2D contour and select the tool. And I'm just going to select out, today I'm just going to select out of the tutorial library, I think. Select the 16 millimeter flat end mill. Select our geometry. So now when I select this here, when that end mill goes around that corner, it's just going to slightly break that edge right there, and also like if I did the pocket in here, it will do that edge right there. It's kind of funny. Tim Paul, many of you guys know Tim Paul. Tim, who also worked for Autodesk and a very experienced machinist, he always talks about breaking the edges so operators don't cut their hands when they're taking the parts in and out, and that's exactly what this will do. When you put those corners there, that will break that edge so they're not sharp. It's kind of funny. So Tim told me that once, that was kind of like his reason, and made me feel a little bit bad because when I used to be at Ridlam, in the beginning, I didn't do this, but I wasn't thinking about people cutting their hands. What a great guy I am, right? I was thinking about time equals money, right? I was all about cycle time. I was all about, I'm not going to deburr my parts in the machines because I need cycle time. I need to go as fast as possible. But what I ended up realizing was that, if you got to go in and deburr an operator has to go into the burr, that little edge in there, I mean, that's a pain in the neck right there to go in with a little needle file. And by me adding, 30 seconds to a cycle time to maybe, I mean, in this case here, just machining around, you maybe have to do that anyways. So you don't even add any cycle time. But even if you're adding a few minutes cycle time on the CNC machine, you can save an operator like, 30 minutes sitting there trying to chamfer things. So that's one little tip I wanted to give you. Another thing I wanted to show you that I used to do, but really don't have anything to do with chamfers, but maybe you find this useful. You see how the cutter starts right on the end here, on the midpoint? If you go in and you simulate this, you will see when the cutter starts, it kind of like go in and starts right in the center. That always means that the cutter always sucks in right there on the edge. That's all great, but it always leaves a mark. You know what is a lot better to do? Just go out of that, go back into your operation, edit it, go to the last tab, to the last thing you can pick in the bottom, so last, and select an entry point like right here. Now the cutter will start right on that corner and not leave that suction mark there. Just one of those small things that will make the part look a little bit better. Now you can start right on that chamfer. Now I want to come back to this pocket here. So like I said, if I maybe go and do another contour, and I go ahead and let's select the smaller cutter. Again, from the library here, select maybe 5mm. If I do another contour here, you will see the same thing. First of all, you will see that with that little chamfer, it's actually going to break that. And then I would also move that entry point. Again, I know that repetition is key. So right click, edit, last tab, last selection you can do down the bottom, and you can select a corner right here, what corner you want to select, and you will see now the cutter starts right in that corner. You don't get that suction mark. Before we get into the 2D chamfers, one other thing that I just thought of while I was prepping for this, you see how I did sharp internal corners. Somebody in the chat right now are like, dude, you can't do that. And that is true. What happens, of course, when we're doing this is, go into the shaft, is that when the cutter, hit play here, it's going to show red collision because I didn't rough all this out here. But what happens, of course, is that the cutter, if this is a finishing cut, imagine we already roughed out most of the pocket, when it comes right there, it's going to bury the whole cutter right in that. It's going to slam right into that corner right there. So what we normally would do if you are modeling, if you are a CNC programmer and you get a model like this, is we would normally go into the model environment and actually put in the fillets that we should use in here. Or you maybe also get the model from the designer with the fillets already in there. Now I selected a 5mm cutter, so half of that radius will be 2.5, right? But that would actually still mean that the whole cutter will come in, or that half moon of the cutter would come in and bury in that corner. So what I many times would do that could help a lot. It depends a little bit upon your machine's look ahead, but one trick, there is a tolerance on everything when you're CNC machining. One trick is to actually add the tolerance of your fillets to your radius for the internal corners. So I'm just going to do the math right in here. So let's say we had a tolerance on 0.125. Now this radius is a little bit bigger, what means that we go back into CAM, and we just have to regenerate it here. You should actually see that now it will not, I'm going to simulate it. Top, whoops. I'm going to go in and play it here. Right there. You will actually see that it's going to walk just, I know it's just that tiny little radius, but it actually is better that the cutter is not just going right in the corner. It actually has to kind of like walk around that corner. You do that by making this radius a little bit bigger. So if you have a good tolerance, you can save yourself a little bit of hassle with that. Okay, enough of that there. So let's talk a little bit about machining fillets. I'm just gonna go, let me just delete these here. So a couple of people have asked me a question. So we have the model here. Let's go in and add a, well, let's say fillet, let's say chamfer. Let's go ahead and add a chamfer on here. Like this, and let's make it, I don't know, nice big chamfer. 3 millimeter chamfer, good chamfer here. Whenever you are driving a chamfer, we always drive the bottom one. So that's the first thing to add in there. Drive the bottom. So let's go back into cam. Now, what you will probably do, if you're anything like most people, you will go into 2D, and you will see that there is a 2D chamfer in here. You select that, you go into your tool, and again, I'm just going to go to the sample library. You all have this, the tutorial metric, and I'm just going to select the spot drill because I used to use the spot. I think it's called a spot mill actually, to both spot for drilling holes and for chamfering. It's good for that. Has a little 45 degree. I'm going to select the edge here and hit OK. And then you get a little warning sign. When you click on it, you will see you didn't get any tool path. And you could also hit the little arrow next to it here, and you will see it says none. And you're like, what the heck? Like, why didn't it 2D chamfer this edge around here? You know, unless somebody told you, you would not know that the 2D chamfer toolpath within Fusion don't chamfer where there already is a chamfer. Now you're like, well, wait a minute. Let me show you. And don't, this makes sense. Let me show you something cool. Let me go in and edit it again. Instead of selecting this edge, let me exit out. Let me select this edge of the insert pocket here and click OK. And now you will see that you get a nice chamfer toolpath that goes around here. And well, wait a minute, why would it not do with the chamfer? Well, here's the magic with the chamfer tool. I did this on purpose. Here it's all perfect, but let me go ahead and make a design change to this model. And I'm actually going to use direct edit by using Q. Select this face here. I'm just going to move this edge like 1 millimeter closer to, so I move this face 1 millimeter closer to our opening. Now let's go back to cam and regenerate that chamfer toolpath. You see how this chamfer toolpath just broke up down in this end? The 2D chamfer that you find down here is intelligent enough to know when it's going to hit something, what in this case would be this, what is this? Like this core sticking up here. It's smart enough to know as it's coming around, if it cannot clear, it will back off. So in this case here, it avoids that back face because it sees that the cutter would actually hit right over here. So that's the smart thing about the 2D chamfer tool that you find in the dropdown. And anybody who ever tried to chamfer something, know that, you know, gouging with a chamfer, I mean, it's just happening. A good example would be if I go in here and create some kind of a pocket. Hit Q. Something like this, and you want to chamfer your part, and you're thinking, oh yeah, I'm going to chamfer, I want the chamfer to come in here and cut in here. Well, with a standard, most standard chamfer tools would actually just chamfer the whole edge, which means you will hit that edge right there. Somebody who have ever tried this know that awful sound when the cutter hits there. But what is cool about the 2D chamfer tool is that it is smart enough to look at its surroundings. So even though you see the whole edge is selected, look at what happens when I do it here. You see how it actually shortens the tool path so that cutter will never hit these two walls. That's the magic of the 2D chamfer. Now, so then one of you guys says, well, that's all great, Lars, but my customer sends me files all the time where the chamfer is already on the part, and what am I gonna do? Oh, I was in the sketch here. I got all my chamfers. Why is it going back to the sketch? I love that there. Why would I, what if I have this chamfer on here on the outside? How do I machine it? Well, here's a cool thing. I'm going to show you something neat. If I go into this contour toolpath, this is the contour toolpath we had before, right, for doing the pocket. If I right-click and hit Edit, and you look on the Passes tab, just try to memorize what you see down here. Now, if I do another contour path, 2D contour path, but I make sure I have a spot drill selected, check out what happens on the Passes tab now. The software is smart enough to know that if you select a chamfer tool, a tool that can create a chamfer, the contour toolpath will automatically add the chamfer parameters in here. So now I will use a contour toolpath to select around that outside where there actually is a chamfer. I hope that this was not too confusing. So first of all, the 2D chamfer tool will avoid any intersections, so it will not gouge your part. That's awesome. But if you already have the chamfers on the part, then don't use that. Then you will use the 2D contour. As soon as you select a chamfer tool with that, then it will turn those boxes on where you can adjust the chamfer. Now, another trick that I used to do, and again, this is just preference. When I used to do any chamfering on my parts, I actually didn't add any depth to my cutter. I did that out at the machine. What I mean by that was, for my chamfer tool, I would literally program it at 0, and then when I was out at the machine, I would add something to the cutter comp. And the reason for that is that if you take like these spot mills or spot drills, sometimes there's a little bit of flat edge on them, and when it comes to a chamfer, it only takes like 10,000ths of an inch, or like very small, I don't know, 0.2 millimeters to make a chamfer look good or look bad, make it look too deep. So I actually, if we go back into to Fusion in here, you will see if I go back into this chamfer operation here, let's go and edit it. You will see that in the Passes tab, you actually have a chamfer width, chamfer offset, chamfer clearance. And the chamfer width would be, and actually if you hover over them, you get like some nice graphics in here that the team have done a really good job with, kind of like give you a visual of what it does. But this is where I would actually program my tip to 0. So I never had to, so I would do it out of the machine. I had some bad luck where, especially if you're running production, you want the parts to look very uniformed. So that's just a little trick. You don't have to do that at all. Okay, so I hope that kind of like clears up any confusion out there. The 2D chamfer is awesome to make sure that you don't collide with anything. But if you already have added the chamfers to it, then you can use the 2D contour. You will not get, of course, the collision detection. That's why the 2D chamfer can't do chamfers yet. It's probably because of the algorithms. The software have to look ahead, right, to make sure that it doesn't hit anything. Okay, let's go to the maybe a little bit more, I don't know, advanced. What about like rounds? So if you have like a round thing around the part here, again, I would actually also use a contour to put that on. There's kind of like two different ways, I think, that you can do this. You can either do it with a radius cutter that always have that specified radius on it, or you can do it with a ball end mill. So I will show you both. So if you have a radius cutter, let's do that. I will use the contour toolpath. Go in and open that up right there. Okay. So when we go in here, you will see. Oh, I can see here we got a question. What? Where are you offsetting the tool for the offset for the tip? That's a great question. So on the spot, let's go back in here. So on the chamfer cutter, edit, go to the passes tab. You can control the compensation on just like you can inside the contour. That you can flip the arrow. So in this case here, it's going to be cutting on the left side of the here. Of course, if I click the other way, it's going to be on the wrong side in this case. And you also have the control and the compensation type in here, how you want it to output it depending on how you do it on your machine. So yes, that's where you control it. Right on the passes tab is where you control that. Same thing for the contour toolpath. Same thing. Edit, go to the passes tab, and you can choose there if you're climb milling or traditional milling right there. Good question. Okay, so let's do a radius cut. So I'm going to go to, again, select the contour toolpath. Let's go in here. And in the tool library, I know that there's not one in the actually tutorial, but that doesn't mean there's not one in the tool library. So you can go to type, and you actually have radius cutters right over here. Click on that, hit OK. I'm going to have to do it up here so I get all of them. Somewhere in the samples, there's one. Let's go down, we're doing metric. That's a free, so that's a radius of 3 there. And I think that was what I put in here. And again, just like I said before with the chamfer, select the bottom edge. That's what you are going to be driving. And again, just to the point where it's the compensation, you can see that on the arrow. You click on the arrow, you can flip the direction if you ever have to. But Fusion, the Canon Fusion, really, I mean, the developers, one of their main things is never gout. So this thing here is, I don't remember the last time where I was wrong. Hit OK, and you will now see that we get a toolpath. And again, the best way to go in to verify this, let's go in and hit simulate, hit the play button. And that is not a 2mm radius right there. I took a 3 radius on the cutter. So whoever modeled that up, Lars, edit 3, go back into cam. Let's update that. Let's see if I did it better this time. It is Friday. It's almost beer time. Oh, that looks much better, right? So now you can see here how the radius cutter is going to come around the corner there. So it comes down and makes that beautiful, beautiful radius right there. Of course, this is kind of like the golden way if you have a radius cutter on here. So just remember, you will touch off the bottom of it, and then you could driving the bottom of the radius. Again, when it comes to radius cutters, I would actually walk them in. So I would run a test cut where maybe I have it backed off in my cutter compensation on the control, a little bit. And then when I come in and so I can kind of like play with it out of the machine, because this can really, I mean, again, just a tiny little bit and your part's going to look like you screwed it up when you're maybe only down, half a human hair or something like that. So next thing that I wanted to show here is what if we are going to if we didn't have a radius cutter, you got to use a ball end mill. That's kind of what used to happen to me many times, unless it was a production job. I'm just gonna hit Q for press pull and just move this one up a little bit. Right, so we have a little bit more we can look at, so we're not so close to this face. Let's go back into cam. Now for this, we're gonna use a ball end mill for that. And then we're gonna use the 3-axis toolpath. What I normally use is the contour toolpath in here, so you can write that down. Now, so let me select the contour toolpath. Let's go and select a ball end mill. And I know that some people, don't get to play much around inside of 3D toolpath. And when I used to be at Ridlam, I actually felt like 3D toolpath was a little complex. So let me just take you kind of through how I approach 3D toolpath. Now I still got 4 minutes left before we hit the half an hour. So I just selected the tool. That was all I did. I selected the contour toolpath. I selected tool. I like to hit OK. Let's see what we get, right? If we see what we get, now we can kind of start breaking things down a little bit. So we of course get more than just the radius, what tells me that, okay, the next thing I probably should do is work with what I'm selecting to machine. Right now it's selecting everything. I feel like many times I have definitely been guilty of this. I would get into these different drop down bar or these different tabs, and you start changing a million different things, and then suddenly you don't really know where and you want to start over. So doing it step by step makes it a little bit easier. So I selected the tool, I hit OK, saw what I got. Okay, good. Now I can go to the geometry tab and maybe select what I want to machine. So it's set to silhouette, but it's just like you shine the lamp from the top down on top of the pot. So that was where I selected everything. Let's try to go to selection and just select around this edge right here and hit OK and see what we get. Now you see that we don't really get anything. What maybe could be a little bit worrisome, why is it not going to machine anything? Well, I wanted to do this just to give you a chance to explain this in here. So the contour toolpath we're using for 3D is really trying to look for vertical walls. And if it don't see any vertical walls, you can't put any toolpath on, it's not going to do it. Again, the development team don't want to gouge you apart. When I look over here and in the selection tab, we just selected that chain, right underneath it, it says the tool has to stay on the boundary, and that's that green line that we selected right there. What could make you think, well, I don't really want the center of the tool, I need the center of the tool to go past that. So right underneath here, there's a contact point boundary checkbox. That is like one of these. What it will do, I'll show you, well, the highlight here if I hover over it, what it will let you do is it will actually let the cutter go past the center line, but it will stay tangent to what it's trying to machine. So I'm going to hit OK here and show you that. Now, by checking that checkbox, we're actually getting something. What are we getting? If I go in here and go normal 2, and let me simulate it, you will see that, let's go to about, so this is about where we selected that chain. Right now, the cutter sees that that's the center, and it says, I can't come past that. But when you check contact boundary, that little checkbox, contact boundary, whatever it does, what it does is it makes the cutter go past that, but just stay tangent to what we have selected. So you will see when we get over here that the cutter, this is still the area. You will see how the round, it lets it go past, but it only machines this. It's just tangent to there, and that's where it ends. This maybe is a little confusing, but I wanted to at least show that so you're not like, what the heck happened? Another thing, when I'm looking at this, it looks like there's a pretty big step over. I might go in and make on the passes tab, make the step over you know, you could make it a little bit small or whatever, how fine you want it. Okay, so there we got a really nice toolpath. Now again, you might be looking at these blue lines and say, well, why are they going so further down the side? But these represents the tip of our tool, not where it's cutting. It's resembling the tip, what means that in the end, we need the cutter to get down to here to be able to create the tangency. Let me just play it through here. So it's able to create that tangency as it's going around there. Does that make sense? I hope that makes sense for you guys. That was about it. I hope that was useful. I hope it gave you a couple of tips to working with machine fillets, chamfers, and the rounds. Again, if I went a little bit too fast, don't forget you can rewind back and you can definitely rewatch it again. It is Friday. I hope you have an awesome weekend planned. I am planning on taking next week off. So if you don't see any live streams next week, don't worry. It's just I have a couple of other projects for work that needs more attention. So that's how it goes sometimes, right? That's about it. You let me know. Thumbs up if useful. Thumbs down if it's not. Be honest. I am going to end the broadcast. So if you're watching the recording, thank you so much. I really, really appreciate it. Hit that subscribe button if you haven't. That, you know, just helps me to go to my boss and be like, look, people actually, you know, like this stuff. And I will jump in the live stream and say hi to everybody there. Take care, guys. Have an awesome weekend.